A very good evening to all of you. I, Dr. Anu Syal, Faculty, Department of Computer Science and Engineering, AI, ML, and Cybersecurity, extend a very warm welcome to you all to the Industry Connect session on Cloud and Distributed Computing, Introduction to DevOps. In order to provide an insight on the topic, we have with us Mr. 𝗖𝗵𝗸𝗀𝗍𝗶𝗃𝗍𝗍. Presently, he is a partner Wipro FullStride Cloud Services with Wipro Digital. Mr. Chakrabarty completed his MTech in IT and Computer Engineering from Indian Institute of Engineering Sciences and Technology, Shibpur, in the year 2000. He has also done a certificate course in project management from Virginia Tech in the year 2007. He has an extensive experience as a senior technologist with business focus, having more than 20 years of rich experience in consulting and execution of digital transformations, domain solution architecture for automotive, oil and gas mining sector, government enterprise architecture, fintech, IT service management for complex system integration initiatives of Wipro, IBM, and PwC, to name a few. He has worked with the major IT giants. He has widely traveled, having worked at client sites in US, UK, Denmark, Kuwait, and Malaysia. His specialities include cloud transformation, assessment and strategy for products, automotive, fintech, and new energy business, business leadership and go-to-market strategy, AWS solution architecture, DevOps automation, digital transformation, microservices, and domain-driven software design, app modernization, and IT leadership. His accomplishments are numerous to state. He has certifications like TOGAF 9 certification, IT for IT certification, project management professional from USA, IBM certified Tivoli service request manager, AWS certified solutions architect professional certification. He has also received numerous accolades like Wipro GEA AHM Q4 Award for outstanding performance and Amazon Partner Program Ambassador for his significant contribution to his field of work. He has numerous publications in journals of high repute. Now, I would like to request Mr. 𝗖𝗵𝗸𝗀𝗍𝗶𝗃𝗍𝗍 to deliver his speech and share his valuable experiences with us. Sir, please.
Absolutely, and thank you so much for that introduction. It always, I'm humbled by that, and I thank you for inviting me to give this lecture. So, firstly, the topic that I will be discussing is on cloud computing and DevOps, because these are fundamental to the way we are seeing the engineering, the digital platforms. All of these are scaling to internet size because of this paradigm shift. So these are the revolutionary changes that we have seen in our lifetime, where we have the likes of Netflix, and we have the likes of Facebook, Twitter, and we have the likes of LinkedIn. And this is the new age, what we call as the industry 4.0 and the digital age, because every every century is characterized by certain certain characteristics, so to say. So last century we were having the IT boom, or what we call as the year 2K problem, and the 21st century is going to be the start of the digital age, and a few more things associated with the digital age, which is also going to be decentralized kind of currency, what we are calling as blockchain. And these are going to be the major disruptors that we will see in our lifetime. I wanted to share with you all a presentation. So I think I have the presenter rights. Let me go ahead and share this presentation. Do let me know if you are all able to see the screen.
Yes, sir, screen is visible.
Okay, excellent. Thank you so much. So we'll start off with the reason I have said it's an enabler to internet scale is because truly these revolutions, these enablers have have given the capability to entrepreneurs, to small enterprises, medium enterprises, to scale to the level of Amazons, to the scale to the level of Facebooks, Netflix, Twitter, any scale, and these are the fundamental building blocks. If I were to talk about that, is nothing but cloud. And the fact is that cloud and distributed computing has become the DNA of our age. Okay, whatever, wherever we would like to work, or we would like to contribute in whichever domain, its fundamental principles lie with cloud. So it's not just I think it is so much imbibed in our day-to-day activities. We do not realize the impact, the profundity of the impact, but it is tremendous. Who are those key players in the market if we look at it? See, AWS, Microsoft, Google, Salesforce. These are the the household names that even child they know, and the reason being that they power the engines of growth. They power what these are also known in the industry as hyperscalers. Why it is hyperscaler? The fact is that they can enable your business to grow as much as you would like it to grow. So the capacity is there is no upper cut on the capacity. So it all depends on your competency. It all depends on the market viability of your product and the reach of your product. So these are the major contributors, if I may use the word, to these newer digital engines of growth. IBM has come up in a big way, and IBM Red Hat that we were talking about after acquiring Red Hat, IBM has become a phenomenal growth engine for Kubernetes, because Kubernetes is changing the way we do cluster management, we do containerization as a service, and it has its own impact in terms of scale. So if I were to have a business which needs to grow 10 folds, 20 folds, and I'm not going to be using the conventional route of virtualized machines and servers, I would prefer to go on cloud with containers as services. So these are the platforms. So today's world is fundamentally governed by platforms and products. It's not governed by what we call as applications or siloed monoliths or applications. No, the reason fundamentally is that it is an ecosystem. We live in an age of ecosystem, and without going too much into the depth and deviate from the main topic that I am here to explain, the ecosystem fundamentally is what keeps this growth engine on. Why? Because ecosystem is not just the contributors, Amazon, Google, Azure, Microsoft, or Oracle Cloud, or IBM. It is much more than that. It is the suppliers, like who are the main suppliers to these organizations? Who are the partners? I work for a company which is a major premium consulting partner to all the hyperscalers. Wipro is a premium technology partner to all of these hyperscalers. So I belong to the partner community. Similarly, who are my distributors? Who are my the organizational customers? Because customers also have profile. I can go for a small customer, I can go for a large customer, I can go for a medium-sized business. So all of these comprise of the of the growth engine, and no one can survive. Trust me, no one can survive without the other. So it is a very symbiotic relationship that we have today. So what are cloud consumers and what are cloud providers? To project it in a very simplified manner, is fundamentally there has to be a network. And today, when I'm talking about growth, I'm talking about internetworking, I'm talking about 5G, I'm talking about the main building blocks which have enabled the cloud growth engine to grow. So if you think of it, a provider will have its own infrastructure, will have its own IT assets, engineering assets, and it will host all of these assets into its private data center. And there will be administrators who will manage these resources. So fundamentally, if you think of the cloud as an interconnected network of consumer network as well as provider network, and they are being fed through ISPs, internet service providers, and backbone services, they comprise of this entire cloud internetworking that I would like to call it. And in between, there are multiple players involved, mainly in the form of internet service providers who are into different categories, very large internet service providers who are global in nature. So these ones are called tier 1. Then there are another classification of service providers, internet service providers who help the cloud service providers to expand, are the regional service providers, which we call as tier 2. And there is another category which is very localized set of internet service providers who we categorize into tier 3. So it's a combined effort of all these tiers of service providers who provide the backbone for the success. So like in real world, success is not just an individual or an organizational success, it is an ecosystem. It thrives on an ecosystem. Now in this diagram, I've just tried to simplify what different services or deployment models, like we call it, can be achieved on cloud. So one is we can have services. A lot of the services that we consume day to day are absolutely cloud based services. Behind these services, there are a huge set of assets, infrastructure, routers, storage equipment, physical equipments like switches, racks of switches and routers, which kind of power these services. So services, I think of it as just running applications, but behind the application, we have a host of other assets and resources. And these are constantly being monitored, constantly being upgraded, patched whenever and wherever it is needed. So that part, that entire cost, if you look at it, it's humongous. And today's data centers, if we look at it, some of the data centers, they virtually consume, some of them consume as much power as a city or a town. So there is another challenge which is growing, is how to optimize the cost behind these data centers. And also there is a climatic impact of climate change because of the huge heat that is generated in this data center. So there are always the plus and the minuses. And so organizations really want to offload some of these bulky overheads and instead focus on the exact nature of their business. So you will see the likes of retail companies, large retail companies, supermarket chains. So these used to run large data centers. Now, it's not sudden, but it's been a slow change that they started offloading parts of their portfolios and the data centers which are running those portfolios to uh, cloud service providers. And when I'm talking about cloud service providers, these are the top ones, but there are plenty of others who use their services and kind of host it, some of the services on their own data centers. So there is a mesh, we can call it, it's a mesh of diverse range of cloud service providers who are taking this load and running their own data centers which has been outsourced. If you look at it from a security angle, this presents a new challenge to the cyber security professionals like yourselves. Imagine that cloud is a multi-tenant environment where we are sharing our servers, we are sharing our storage, we are sharing our network connectors. We have lots of shareable resources. And how is it that we can protect these shareable resources from unauthorized or from vulnerabilities by ensuring that there is a proper security and check and control. And this is an area of study. The common known facts are there that all the major cloud service providers, they assure that there will not be any breach of security. There will not be any breach of data, sensitive data leakage. But there is the chance always remains. So that is a big challenge for the organizations, the Fortune 100 companies, the Fortune 500 companies, to really have a trade-off, a balance between how much to cloudify and how much not to cloudify and retain. So that part is a top management decision. For example, in my career, I have seen banks are the first to adopt technology. That's a fact. And banks are extremely finicky about data. So their main goal is to ensure that the customer's information, the personally sensitive information, what we call in the industry as PII, that PII has to remain within the confines of a specific location or specific geography due to a governmental regulation. So some of you may have heard of what we call as the GDPR in Europe. So it means that a lot of the customers' data cannot be hosted outside the geographical boundary of Europe. So that presents another dimension of challenge, that how you can scale at the same time you need to manage this kind of constraints. So this particular slide I wanted to bring up because to lay a stress on how two organizations are trying to access a common service which has been which they are authorized, and there is an overlap of their trusted zone. So anything that we call within the DMZ is a green zone where you trust the traffic, you trust the request, but at the same time, this is also where cyber attacks happen. This is also where multiple threat parameters are presented. So this is a trade-off that we are trying to make a judicious use of. To what extent we should go to cloud and what extent we should retain in our private data centers. The cloud provider characteristics, if I can summarize, it will have a measured usage, it will have resilience, it will have elasticity. So what is measured usage? One of the things, the pay-as-you-use model, this is an old model, and there are lots of caveats associated with that model. It's not just that pay-as-you-use. You can have multiple ways of subscribing to the services. So different cloud service providers give you different options. So for example, AWS gives you an option of going for reservation for a period of 3 years, minimum 3 years, where they give you huge discount. All the services are made available to you, including their SLAs are provided. The other side of the story is that you can auction, that you can do a lot of the auctioneering if you are if you do not exactly need a very stable set of servers or set of applications to be made available. So you can do spot pricing, you can auction you and get a very reasonable priced resource. So there are many ways. Resiliency is where we are talking about how the cloud is able to restore its services. So there is in the context of non-functional requirements, which is a very big thing for organizations. MTTR, which is the mean time to restore a service, becomes very important. And businesses around the world, they try to keep it as minimal as possible, especially the financial sectors, the life sciences sectors, the hospitals, where they're monitoring very critical patients. All these applications need to be extremely resilient so that they can restore their services immediately with minimal loss of data. Elasticity. Elasticity is when we talk about the forecasting of capacity. So a lot of the earlier concepts around IT infrastructure used to be that how much should be the IT spend, because you had to take an estimate. Now that's not the case. You spend as much as you need to, and you can actually schedule your IT spend such that it doesn't cross a certain ceiling, an upper ceiling. So there are ways and means of making sure that whatever you have projected as your future growth stays that way, and you do not over consume the resources. Generally, under consumption is hardly done. People always tend to over consume the resources because of the wrong estimate. So elasticity gives you that flexibility of scaling as much as you want on demand, and then going back when you do not need those services anymore. On demand, this is the word that comes most often to everyone when we talk about scaling. So like I said, I started my discussion with scale. So this is a phenomenal thing because it's like any utility bill or a utility service which you can turn on and turn off. If you do not need it anymore, you can terminate your contract. You can just go out of that contract. And if you need it, then you constantly, you will be billed for what you consume, nothing more. So there is no strong upfront capital expensive. It's all operational. That is the key thing here I want to bring out. So organizations do not waste dollars on major capital expense, but rather on consolidating their IT cost, downsizing it to the extent possible, optimizing the what we call as the FinOps, the financial operations of cloud to the extent possible, charging it to the right businesses so that you know exactly which line of business has consumed how much of the resources, and you can do a complete audit of the cost that has accrued. The other thing is, like I was mentioning, the multi-tenancy. So this is the new principle of cloud. If you look at it, every customer is a tenant who is subscribing to some of the services. And services are, of course, wide range of services that we'll talk very soon on. So multi-tenancy is the concept on which the cloud is principally based on. And this has its plus and minus points, but mostly it is extremely advantageous, and it is secure to a great extent. So so we should be really kind of thankful to some of these hyperscalers, the way they manage the data security, the way they manage the shared resources. If you look at the kind of the constructs of a shared resource versus having a single tenant with no sharing of resources, it's quite simple to project, but it's difficult to really kind of administer that level of isolation. If there is a fault, if there is a breach, then it can be catastrophic. So if you look at the multi-tenant feature, the storage is being shared. There are multiple services which are being offered behind the scene by these underlying storage and the infrastructure, but nevertheless the hardware is shared. And we have a technology which is called virtualization. All of you know it, I know. So different products are used to virtualize the hardware and make the device calls and all the lower level machine interrupts and commands kind of completely abstracted, and so that you have a virtualized machine which is a complete server by itself and can run its own guest operating system and can host multiple applications. So, but what is fundamentally remains is that the hardware is shared. So the underlying storage is shared. So what does it mean? It means that there will be some latency. The latency will be inbuilt into the system because of the fact that the instructions, right from the virtual machine instructions, right up to the level of the hardware which is translating those instructions and making the making the execution possible, goes through several layers of OS. One is, of course, the guest OS, and the other is the underlying host OS. So there are latencies associated with it. So nonetheless, the problem here is that the storage is shared. Any breach can happen unless and until you have a very foolproof isolation mechanism. So isolation means that if there is a breach or if there is a failure of hardware, then it does not cascade across the entire servers, impacting all the services which are being hosted. So the fault is extremely resilient, so it can be brought back to normal very quickly, and reducing the impact radius. So this is one of the fundamental things for which cloud today is able to survive and thrive, even though such is the nature of the cloud services, because everything is shared. So if you look at it, there are few models, deployment models in the cloud world. So one is the infrastructure as service. So if I am a large business, I do not want to own any infrastructure whatsoever, but I have very good software delivery teams who can build me any kind of applications, business applications, fantastic architecture, fantastic scale. So I would go for the infrastructure as service, because that entire cost is offloaded to a cloud provider. And what it really means is that hardware, the firmware, the operating system, all of this is now under the ownership of the cloud service provider. So I am only left with developing the platform, developing the services which will run on those platforms. So this is a typical example. And what it really means is that you are losing partial control. You are not losing complete control. You still have control over your platforms. You still have control over your software services, but you do not have control over your hardware. So this is a good thing because of the cost and because you still get to control your data, because platforms run on data. They have databases which are running as services or platforms. So you still control that. And this is a very good way for financial institutions to actually thrive in this economy, because their main concern about the customer data, the security of the data, the infringement of the data remains sacrosanct. The other aspect is the platform as a service. So what is this platform as a service? If we look at it from a holistic level, platform means different things to different people. And today's world, it's entirely based on platforms and products, because the nature of the economy is such that you can only scale if you have such a thing as a platform or a product. Individual siloed applications, small, tiny, weeny enterprises cannot thrive because it cannot scale. As simple as that. So platform as a service means that I have my entire runtime environment under my control. I have my execution under my control. I have all the data that I require to run this engine under my control. So this, if we fundamentally kind of decompose the layers, this has a runtime environment, and this has a data store, and this has some sort of application running on top of it. And there are different architectures involved, but without going into too much of detail, we can fundamentally say that this is the construct of a platform as a service. A very good example of a platform as a service is, some of you might have worked with, say, SQL Server, which is running on Azure. So Microsoft SQL Server is an example of a platform as a service. DynamoDB, which is a NoSQL database, is an example of a platform as a service. There is another construct which is coming up in a big way, is the application platform as a service, APaaS. What we call, what's so unique about it is that today's world, you want a faster time to market for your products. You don't have the luxury of doing a full-blown software development life cycle and doing a release, which I will come to later, over a period of 1 year. That luxury doesn't happen. So, so to do a fast market release, we have products. These are actually platform-centric products which accelerate the pace of your software delivery in terms of design, in terms of development, in terms of testing, all of it kind of baked into one, which we call as application platform as a service. And a good example is Microsoft Power Apps is a very good example of APaaS. So this is the example of a platform as a service. When we say software as a service, this is also very, I mean, this is the lowest level of control. That means you practically have no control. And this has both a lot of positives and there are some repercussions. The repercussion is you have no control. You are simply an end user. So organizations, so for example, Gmail, do I have any control? No, I don't have any control. It's a SaaS from Google, Okay, Google is my provider, and Google, I consume it. So these are the typical examples of where we are doing a trade-off versus control. Trade-off in terms of how much control I have as a consumer and how much have I foregone due to the convenience. Hybrid and public cloud. This is a fantastic concept which is coming up and where we are seeing that organizations are not completely at ease in migrating their entire workload to cloud. We are seeing a partial, a private data center being connected to a public cloud provider for some of the other services. So, for example, a bank, I would have my data stores, I would have my all the the sensitive data I would have to retain within the confines of my data center. But the other lower critical applications, business applications, I can offload onto a data center, onto a public cloud service provider. So these kind of constructs are coming up, and this is called as a hybrid cloud. There is one more construct, and which is coming also in a big way, is multi-cloud, and where we are saying that all these service providers, majorly Amazon, Google, Azure, Oracle, and IBM, all of them, if they were to have interoperable services, and if organizations, instead of putting their bet on one player, have a mix, which makes the risk quotient lesser and the benefits also higher. But there are lots of tactical problems that happen if we have a multi-cloud provider. And so one of them, of course, is going to be the security. Then there is the convenience part. And there are some unknown aspects which nobody has actually faced till now, because these things has not taken a industry standardization, so to say, right? Consortiums are there, they're coming up so that they have a standardized way of interoperability. Say, for example, AWS services can talk with Google services, and Google services can talk with Microsoft. But that kind of, the standardization has not come up so far very well. Then there is the entire enablers due to the broadband network. So we are talking about 5G today, which is going to completely revolutionize the cloud industry. What's going to happen is the transport layer, which is the TCP/IP layer, the UDP layer, is going to have a humongous capacity. And as a consequence of which, the video streaming, the gaming industry, all of these industries are going to fundamentally scale maybe 100-folds, if not more. And the convenience to the end user is also going to be tremendous. So this throws away a huge possibility. And if you look at the building blocks, which I was just explaining earlier, who are my building blocks for this cloud economy? It's nothing but the broadband technology and the internet architecture that we have. Fundamentally, it has a backbone. This is one component. It has a consumer's network. And then this is connected through the internet service providers, both large and small, to complete the entire supply chain, or what we say as value chain, let's say, from the consumer network all the way to the provider network. So if any one of these building blocks by chance gets interrupted, like we hear sometimes the undersea cable got disconnected, or there was a abrasion in the cables. So this can have a profound impact to the New York Stock Exchange, and instantly you lose millions of dollars. So these are some of the the worst nightmares that you can think of, but the positive is far, far outweighs these nightmares. So I think this is a more of an academic part, but I just thought that you as cybersecurity students, you would be knowing all of this. And I just wanted to ensure that this is the fundamental block which drives the cloud to the level that we are talking about. So the all depends on your transport layer and your application layer. The more and more protocols that it comes to support, the more and more growth that we will see happening in our lifetimes. So for example, UDP. UDP is a protocol which supports live video streaming, which is a very intense, bandwidth intense workload. So, so if this type of protocols, but the problem with the UDP is that it is connectionless. So you are again doing a trade-off where you really don't care about the consistency of the packets, but you care about the content, and you care about the speed, the real-time speed. So this is a example of a connectionless but extremely efficient way of data exchange. The other is the application layer. So applications, as we progress more than HTTP, which are fundamental protocols of the internet, if there are newer innovations happening, we have wireless markup language. So if there are even more sort of innovations happening in the application protocol stack, which allows us to have more of diverse applications supported, because some years back there was no concept of JSON, right? XML was the standard data format, but now we have JSON, which is a much more lightweight data format. So if we have a further innovation which can support a format like JSON, then that's the sort of innovation that we are looking for in the digital age. So this gives you an idea about what the protocols are. This is the one of the very interesting principles, and that explains the cloud domain very well. So everything is governed by a set of business goals. So what does your organization want to achieve through cloud? So if you look at it, these characteristics are achieved. What are those characteristics? Some of them, as we have already discussed: scale, elasticity, metered consumption, availability. So these are the business goals that any organization in today's age is trying to achieve 100%. And these are realized through these principles. So principles is the important thing of cloud. What are my cloud principles which make cloud native applications thrive? Because any application which needs to leverage the power of cloud has to have these principles embedded in it. So any application that we develop on cloud has to conform to these principles. Latency aware. What does it mean? As I saw it, that due to virtualization, and imagine the level of internet working, the communications from whether it is at the TCP/IP layer or the HTTP layer, the number of hops that the data packets have to make automatically induce latency. No one can say it's latency free. So with, of course, 5G technology coming, it will be reduced, but no doubt. But even then, there is latency. So latency aware is important for the application. So whatever applications we build, we need to track this latency. And there are certain patterns architectural patterns which organizations have to understand to realize that. So these examples are stateless. You cannot have stateful applications because they will not serve the purpose for the cloud native capabilities. To leverage those capabilities, you need to be stateless. Similarly, parallelizable. Can you scale? Can you handle range of requests which are running in million requests, let's say, per minute? So how do you scale and handle those requests? Amazon typically does that, or Netflix does that, LinkedIn does that. So there you need to have an architecture or an application which can really scale that fast without compromising performance. So you have, multiple horizontally scaled containers servicing those requests. So this is a more of what we say as non-blocking architecture, where your application should be architected in a non-blocking way, so that you do not depend on the responses being generated from the service provider. None of the applications should be completely stuck because of expecting a response from a service provider. So it should be in parallel. That means any request that I am sending, I fire and forget. So that is the kind of architectural decision that an architect has to take in order to make the application leverage the cloud capabilities. The other is the failure aware. So the applications need to be failure aware, where the resiliency comes into picture. So it cannot be very chatty application. It has to be autonomous, it has to be non-blocking, it has to be asynchronous. Asynchronous is one of the key things that we try to achieve in our architecture for applications to be cloud native. So this in general, I mean, this is really it's a short form, what we like to call as 𝗖𝗵𝗱𝗶𝗶. So life is L as in latency aware, failure aware, elastic, and you can make out that what the A is availability and R is resilient. So each one is standing for, I have it here, latency aware, instrumented, failure aware, event driven. So everything has to be event driven. Why? Because if you have sequential way of executing things in your application, then it will be more of synchronous in nature. So one has to complete, then other task can begin. But rather, if you do it through a queue, a message driven, that's why we call it a message driven architecture, so that every message can be handled in parallel. It can be executed in parallel. That is more performance oriented, that is more robust and more scalable, more importantly scalable, because each event is independent of the other. It has no bearings whatsoever. So any event which is pushed onto a queue, for example, will be handled by a service independent of the other. Then the security part. Secure. These services have to be fundamentally secure. So applications and the services that these applications have to be made secure. So you can do this security through multiple ways. For using digital certificates, you use encryption for the data, you use private keys for signing your APIs. All of these come under that broad context of application and service security. Automated and resource consumption aware, very important. We say this is automated and resource consumption. So your services need to be self-aware that they have crossed a threshold. So that your monitoring, in AWS, there's a feature called CloudWatch, which is so smart, it's able to, you can set up matrices and you can say, the moment this service crosses the 50% CPU utilization threshold, shut it down, or launch another container, or launch a fleet of containers to relieve the load on this particular container. So this is another way of completely automating your monitoring side of things, so that it's human independent and it is having the intelligence by itself to kind of, you know, stick to the point or not cross the ceiling. Yeah, so I will not delve too much detail. I know I'm getting into a lot of details. So these are some of the cloud native characteristics. When we talk about cloud native, there is always this virtual shared infrastructure. What it means to, there are two parties involved, what it means to consumers like us and what it means to the cloud service providers. So there is a lot of things that it means to different set of people, but in a nutshell, this dynamic nature of cloud is extremely useful because it gives you the flexibility. It gives you, based on your requirement, you can plan out the sort of services that you will be requiring, and you can manage your cost much more efficiently, right? So that's one. Similarly, the on-demand capacity and self-service, it gives you that control, that you control your usage. It's like a meter, right? So all of this comes with lots of positives in terms of managing cost, optimizing performance, operations, all of this. And this is done entirely through API. So that's why in today's DNA and age, if you look at all the cloud service providers, one thing remains very common: the way they give you the autonomy of managing your own resources so seamlessly using APIs. APIs means just you know, everything is hidden from you. It's abstracted, and you can get the service that you need at the click of a button. So elastic scalability. So these are all the common things that we talk about scale, talk about cloud. So provisioning, deprovisioning. So again, in today's DNA and age, what we are talking about in cloud is destructible, dispensable infrastructure, because infrastructure is a cost, is a botheration, the liability. So how do I destroy it the moment I don't need it, right? So everything can be scripted. We are talking about Terraforms and we are talking about CloudFormation for that reason only, that use it when you need it and destroy it when you do not need it. So that's the part about the elasticity. Metering usage we have discussed, and there are different contracts. So both Microsoft, Amazon, Google, Oracle, all of them have different types of contracts which can give you a very good value for money, depending on the tenure, depending on the duration. The longer your service contracts, the more discount you will get. That's the general principle. Then the availability of common network. What does it mean for a cloud service provider? So there are standard protocols which are being, which are supported by all cloud providers. And on top of that, there are emerging things which is now no longer so much emerging as software-defined networks, where you have a stack of protocols that can be supported, and it can be treated as a pay-as-you-use model. So networks can be created, networks can be destroyed, networks can be self-monitored, self-diagnosed. All of those things can be built into the network. And then there is a code failure, resilient, and latency aware. So this is what happens is, how do you make your systems more resilient to failure? And how quickly are they able to bring back the services? The same thing we talk about in Amazon's world, we talk about availability zones, we talk about data replication across multiple global regions. So it is not only the data centers, which is part of the region, but it's also across the region. So across continents, that you can have the data replicated within minutes and made available to some customers in another part of the world. So now we come to the part where we talk about the how is this new age technology made possible? I mean, what are the key ingredients to it? So in this economy, the key ingredients would be the application architecture, the infrastructure, the development processes, and the pace of release of software applications. All of these have a contributing effect in making the cloud economy thrive. Application architecture, I hope I've been able to kind of communicate or message it correctly, that this is the core of things, because if your software applications are not able to leverage the cloud native capabilities, then they're of no use. They cannot be a pillar in your growth. The other is the infrastructure. So today's world, we don't talk about infrastructure. Infrastructure is also code. That's why we say infrastructure as code. And then how am I going to deliver all of these components, right? I have the application, I have the infrastructure, and how do I make it work in a very fast time to market? And that's where the DevOps part comes in. So I've kind of linked DevOps to the success of cloud. You see where it is adding value. It is all connected with the delivery process or the development processes, and that's why DevOps is a big thing. I won't go too much into detail, but I thought that I'll tell you some of the important activities that cloud engineers do, right? You see, today's age, we are talking about modernization of the applications. Before they move to cloud, there are many things need to happen. You cannot just move a very legacy system to cloud. You need to do certain things and then move it to cloud. So there are different ways of doing it, what we call as tolerate, invest, migrate, element. And in simple words, we say the 7R lanes, what's called as the rehost, refactor, replatform, then repurchase, retire. So all of these have a significance. You don't spend money on a very legacy piece of code when you can easily replace it, right, with something having a more microservice driven approach, or microservices for that example. So there you need to re-architect. So these are the 7 steps. There are not 4 actually. The practitioners who actually do this work, they have come up with 7 R's. Each R signifying something, either replace or retire or rehost or repurchase. So all of this comes into the picture. Why do we modernize? Why do we replatform? So any cloud engineer, if you look at it from the point of view of, there are 3 main dimensions to observe. One is the outcome, the business outcome. It is the user experience, the process, the intelligence. So every application, as we kind of modernize our platforms, we are seeing that there is a huge appeal in the customer experience. If you do not have a fantastic customer experience, it's not going to thrive in market. As simple as that. So so it's not just the intelligence or the business process, but it's also the attractability of the app. the cost angle is phenomenal, because if you go on acquiring technical debt with your old legacy platform, you are going to be beaten by your competitors and you are ultimately going to lose the market. So how do you, reduce your technical debt? How do you reduce your obsolescence, technology obsolescence? And how do you bring in the new opportunities, right? So for example, if you are a bank and you want to modernize your legacy code, you would piggyback on a cloud provider likes of Amazon, and you will say, hey, Amazon, give me a new way of containers, managing containers using Kubernetes, elastic Kubernetes services, so that I can scale 1 million customers over 3 geographies. So this will be the kind of new growth that everybody is looking or counting on from the cloud perspective. Agility. Another key thing that all cloud practitioners look for is agility, and basically the way you will deliver your stuff. And that's where the DevOps part comes in. The speed of change, scalability, innovation, everything has to be go in sync with each other. So if you look at the lower part of it, I have divided into 2 areas. One is development platforms and development processes. So DevOps is an implementation of an agile manifesto. So what it really means is, how do you do your delivery processes, software delivery really, really fast to market without impacting your business, without impacting the quality of the service? That's only possible through DevOps and CI/CD pipeline. So what is that CI/CD pipeline? Before we go there, I'm just going to give you a small idea about what the CIOs, and this is a Gartner study that was done on all the CIOs of large organizations and what they have to say. 60% of those surveyed use APaaS or container as a service, and 44% use LCAP. What it means is, I explained earlier, that there is application platform as a service. Today's age, you do not have the luxury and time of time. Time to market extremely fast. It has to be fast. So what you do in that case, you use your entire platform to design, develop, build, test code in the fastest possible manner. It's like a production line, assembly line. So quicker the better. So that's how this application platform as a service and low code, the concept of low code application platform has come in. Power Apps, there are plenty in the market now. Today you talk about platforms and products, which I started off with giving you the summary of it. So if you want to be successful in this domain, you have to think about low code. You have to think about application platform. Okay. So now coming to the DevOps part. So the underlying factor for the release, underlying factor for the delivery means that you have to talk about DevOps, because this makes your software release that much easier, faster. Look at Facebook. Facebook's engineering team, they have releases practically every 1 day or every 2 days or even earlier. Google have releases every minute. So these are some of the stats that we come across, and it's mind-boggling, because normally for an enterprise of whatever shape and size, if you are to have a software release with that frequency, imagine the level of preparedness that must be built in. So that's why I generally talk about deployment and release, because people are just using these terms interchangeably. Deployment is the installation of the software for a particular environment, and release is completely different. Release is making a functional feature of a software available to a set of users or to all users. And that's why we have beta releases, alpha releases of software. Any enterprise software release will undergo alpha, beta, and then it will hit the live customers. So how frequently can we do the release? So if you look at it, we can do it through two ways. One is through the environment based, where we have patterns like, I released my code to development, to test and production, on I expose a certain feature only to a certain number of people in my production environment. I do not make it completely live. So these are examples of environment based, where I'm releasing into particular environment. The other is what we call as dark launching. This is a very important term. And this is not really, if you are not a product company, you will hardly use it. But product companies definitely have to use it. So where we are talking about features, software features, which you are configuring through small changes, not massive changes, and making those changes available to select people, select users before making it go live. So these are some of the differences in the deployment and the release patterns. So again, deployment and release are two different things. What is DevOps in that perspective? Before I go there, I just thought of telling you some of these things are very important from a DevOps perspective, the release patterns. So if you look at it, I mean, one of the very common ones are canary release. For example, Facebook, right? If you look at Facebook, before they release a complete new feature, they want to test the feature with a select few people. So that is an example of canary release. A small segment of that live user, in Amazon, they do it all the time. So before they launch a product in Amazon, they will go to their channel partners. They will come to Wipro as a partner. Hey, can you give me some, I need to test out a new feature. So let some of you be that testing team and test it out for me, how before we actually hit live production base. So Facebook also does it, LinkedIn does it, all these major big platforms and products companies, they do it. So where we test it out on a small group of people before rolling it out to the larger, wider use. Then we have the DevOps team construct. So what's really good about DevOps is that it gives you the sense of E-shaped skills. If you look at the kind of the plethora of skills that are there in the market, but what is missing is skills which are sometimes very deep, but which enable a person to wear multiple hats. Say if you are a database administrator and you want to play the role of a sysadmin, or you want to play the role of an application developer, that's also possible. And that is the sort of capability that DevOps construct talks about, that you have cross-functional interoperable team who have both the operations capabilities, that means system admin, database admin, all of these, plus you have the core development capabilities who can develop code. So somewhere there is a fusion. So from an I-shaped means extremely focused skill set, where an application developer or a seasoned operations lead can play multiple roles in the form of E-shape, which means both generic and deep in some areas. So this is the critical thing. You have a team who are self-contained. That means if there is a production issue, my developer can fix it. If there is a development issue, my production operations guy can fix it. So that's the kind of paradigm or pattern that we are looking at. A typical construct for a DevOps team will have product owners, because ultimately what are you doing? You are shipping production quality code every day into your pipeline. So you need to have, you need to imagine that it's going to go live every single day with zero flaws. And the main the principle behind it is that you go with the product mindset. You go with a before you actually do a product rollout, you would do a demo. So very important for a DevOps team to have what's called as the end of sprint demo, because then you break your the construct, whatever you started off with, into smaller user stories, or say, for example, your requirements. Instead of having a requirement document which is 100 pages long, you start off with a very small user story, and you ensure that you complete this within a week, because typically the life cycle of a DevOps team is 2 weeks, and then a new sprint starts. So so imagine that you will not have a single release after 1 year. You will have daily release with a very few set of features, and which is governed by a product owner who has set up a small number of product backlog items. So these are some of the terms that we talk about when we talk about DevOps. DevOps has the potential of huge amount of it has got huge amount of respect, by the way, because of the way the product engineering teams operate using these constructs. It is very suitable for product, for service companies. Also, it is very suitable if you have, for example, if you are building a product and you want to do an MVP, you want to do a prototype of that. So we all start off with a very small construct, DevOps team with a product owner, with a scrum master, and a set of engineers. We do not start off with a massive large 40-member team. No, that's not the trend. So this is by and large the construct of DevOps team. Now, just to come to the point, what is DevOps? So if I were to summarize DevOps, I'll just say 2 words: continuous integration, which is the development part of it, and then there's a continuous deployment, which is the operations part of it. Now, there is a complete handshake, and for any team to be successful, it's been found that lesser the number of handoffs, and therefore you have a team construct which has all the skills that you need for development and operations, so that you don't have to hire somebody from outside again to do that job. This is the fundamental. Continuous integration is where you all know it. I'm just repeating for the sake of this lecture, that you go for a small batch development. You go for some of the things like trunk-based development. You make sure that any commit or any change that you push into the trunk doesn't break the applications which are already deployed, and you ensure that it is properly tested. So all of this, if 3 main things, if I can just summarize, one is small size development. You can't do massive development with DevOps. No, that's a big no. Small development which have integrated, tested, working, and potentially shippable code to production, like you're selling, as if you are releasing to production every single day. That should be the mindset. So it's a lot to do with the mindset also, a culture. A DevOps, what we call as a DevOps culture. That means you do your coding so well that you don't expect a flaw, but you do it in small bits. You do it in small batches. So that's the integration part, where we do the build and the testing, and we merge it with the trunk of the main branch. Then we talk about the continuous deployment, which is the operations mode. Here we have the build, we have the deployment done, but now we want to ensure that it is installed in the right environments. And where I told about the dispensable environment, so environment is also dispensable. So we deploy this code onto different environments. Example, dev, test, production, and we ensure that it is all done automated way. How is it possible? Well, it's possible if you have constructed a deployment pipeline, what we call. So in that pipeline, what you're essentially doing is you are ensuring that the integrated builds which have been pushed to the trunk are not breaking anything. You perform a series of tests, which is both your static code analysis, SonarQube, which you use to test vulnerability, as well as your test scripts automatically testing for flaws, validating that it is fit for purpose. And then you are reducing, you are basically creating an environment, again through code, because there is no manual intervention, it is scripted. You have a single click deployment, what we call a single click deployment. That means you're right from the build, test, install, or deploy. All of these operations are kind of orchestrated seamlessly in the deployment pipeline. So this gives you the operations mode. And then there are different ways of releasing it. I just wanted to express this as part of my lecture today. I'm open for any questions. I hope that I have been able to inspire you or motivate you into becoming a very strong architect or developer, whatever your ambitions are. So I will stop now.
Thank you, sir, for sharing all the valuable information with us. It was indeed a treat for the ear to have been listening to you today. Now, keeping this fervor on, let us give an opportunity to our students to interact with the eminent speaker, Mr. Chakrabarty, through a question and answer round. So if anybody among the students wants to interact with Mr. Chakrabarty, may come forward. Students, if you want to ask anything, you have any doubts, you can ask your questions.
So was I very fast or something? You didn't understand what I said?
No, sir. I feel that everybody has understood the topic. In fact, it was very clear, very well prepared, well managed and organized. So everything was quite clear to everybody. So maybe that is why they do not have any kind of questions.
Oh yes, that's also that possibility is there. Oh yeah.
Yes, sir.
We always think over the worst, right? No questions means he couldn't understand anything what he said.
No, sir. It can be the opposite way as well.
I sincerely hope so. And I
wish
everybody the very best for their future. And since you are all budding, developers, engineers, architects, you'll. I hope to, see you as potential contributors to this new world, right? Which we are now, totally into, right? Especially around the multi-cloud platforms and products. That domain is very much a blue ocean, right? And all of you can be massive contributors there.
Thank you so much, sir. So with this, we come to an end of this wonderful session. But before calling it off, it is customary to thank all the people who have directly or indirectly contributed for the success of the event. I, Dr. 𝗂𝗍𝗄𝗏, on behalf of the Department of Computer Science and Engineering of Jain deemed to be university, and all the students extend a very hearty vote of thanks to the Department of Computer Science and Engineering, powered by FutureIn's technologies, for providing us this wonderful opportunity to conduct such Industry Connect sessions on every Saturdays. Also, I must mention our sincere thanks to our head of department, Dr. 𝗍𝗶𝗍, for providing an encouragement and enormous cooperation for making this event a success. I would like to extend a special thanks to our guest for the evening, Mr. 𝗖𝗵𝗸𝗀𝗍𝗶, for the thought-provoking session that has inspired not only our students, but all of us present here. I acknowledge my gratitude to all the faculty members and the lovely students who contributed to the success of this event. Once again, I would like to thank you all for being with us this evening. It's been a great pleasure. Thank you so much.
Thank you so much.
I would like to request the students to click on the link shared in the chat box and fill out the survey form that has been shared. Once again, I would like to thank you all.